When a problem feels huge, your brain can freeze. That is totally normal. The trick is not to solve everything at once. Instead, break the problem into smaller steps. Once you do that, the big scary thing becomes a series of simple actions you can actually handle. Coding is really about solving problems in a clear way. You are not just typing commands, you are figuring out what needs to happen, in what order, and under what conditions. That is why strong problem-solving skills matter so much in programming. A flowchart is like a visual map for your thinking. Instead of writing a long paragraph of instructions, you use shapes and arrows to show how a process moves from one step to the next. It lets you see the logic instead of only reading it. A lot of beginners jump straight into code and then get stuck. Flowcharts help you slow down just enough to think first. When the plan is clear, the code gets easier. You make fewer mistakes and you understand your own logic much better. Most flowcharts begin with a start symbol and finish with an end symbol. These show where the process begins and where it stops. That may sound simple, but it matters. Every logical system needs a clear beginning and a clear finish. A process step is an action. It is something the system or the user does. Examples could be open the app, calculate the score, or save the result. In a flowchart, process steps are usually shown as rectangles. Think of them as action boxes. Sometimes information comes into the system, and sometimes information goes out. That is input and output. Input could be typing your age or entering a password. Output could be showing a message, a score, or a result on the screen. Decision points are where logic gets interesting. A decision asks a question, and the answer changes what happens next. Usually the paths are yes or no, true or false. In a flowchart, this is shown with a diamond shape and branching arrows. Arrows might seem small, but they are a big deal. They show the direction of the process. Without arrows, you would not know what happens first, what happens next, or which step follows which. Arrows are what make the chart flow. Sequence means the steps happen in a specific order. For example, you wake up before breakfast, not after leaving the house. Computers also follow order very strictly. If the order is wrong, the result will often be wrong too. Branching happens when one question creates different possible paths. Imagine asking, is it raining? If yes, grab an umbrella. If no, just head out. That one question changes the next step. This is how programs make decisions too. Flowcharts are not only for code, they work for real-life systems too. A vending machine, a school routine, or a snack choice can all be mapped with flowchart logic. That is because flowcharts are really about clear thinking, not just computers. Let's look at a simple weather example. You want to go outside, but first you check whether it is raining. If it is, you take an umbrella. If not, you just go. That is a tiny but perfect example of decision-based logic. Apps and games also follow flowchart-style thinking. On a game menu, a player might choose play, settings, or exit. Each choice leads somewhere different. Behind the scenes, that menu logic can be planned as a flowchart before any code is written. Login systems are another great example. The user enters a password, and then the system checks whether it matches. If it does, access is granted. If it does not, the user may need to try again. That whole logic path can be diagrammed clearly. Not every process moves straight forward. Sometimes a step repeats. In a flowchart, repetition is shown by drawing an arrow back to an earlier step. This creates a loop. Loops are important because many real systems repeat actions until something changes. Here is a simple loop example. Suppose a system asks the user to enter Y or N. If the input is not valid, the flow goes back and asks again. That repeat until correct pattern is super common in coding and in everyday app design. A good flowchart should be clear, not crowded. If everything is squeezed together with arrows going everywhere, the logic becomes hard to follow. Clean spacing, simple steps, and easy-to-read branches make a flowchart much more powerful and much easier to understand. One smart habit is to break large logic into smaller chunks. Instead of putting everything into one giant step, separate the ideas. Ask for input, check the condition, do the action, show the result. Smaller pieces make the system easier to build and fix. Flowcharts and algorithms are closely related. An algorithm is a step-by-step method. A flowchart is that same logic shown visually. One uses words in order, the other uses symbols and arrows. Different format, same thinking underneath. Tracing a flowchart means following it step by step as if you are the computer. You begin at start, follow the arrows, answer the decisions, and see where the path goes. Tracing is one of the best ways to test whether your logic actually works. Let's trace a grade checker. A score goes in, the system checks whether it is above the pass mark, and then it shows pass or fail. If you test different scores, you can see whether the chart behaves correctly in every case. Flowcharts are amazing for spotting missing steps. Sometimes you think your idea makes sense, but once you draw it, you realize something important is missing. Maybe you never asked the user for input, or maybe one branch has no output. The gap becomes visible. Sometimes written instructions are harder to scan because they are packed into sentences. A flowchart can show the same idea more clearly at a glance. Your eyes can instantly spot sequence, decisions, and branches. That is why visual planning is so useful. This chapter is setting you up for Python. Later, when you learn of statements and loops, you will realize they are just coding versions of decision points and repeated paths. Flowcharts are helping you build the logic before the actual syntax shows up. Here's a relatable example. If your homework is finished, maybe you can relax. If it is not, then you need to study first. That is a simple decision flow. Real life is full of these little logic systems, and they map nicely into coding ideas. What playlist should you play right now? That depends on your mood. If you want to focus, choose one list. If you want energy, choose another. If you want to chill, choose something calmer. A flowchart can turn even personal choices into logic. When building a flowchart, always begin with the goal. What is this system supposed to do? If the goal is fuzzy, the flowchart will also be fuzzy. But once the goal is clear, the steps, questions, and outputs become much easier to design. A strong way to build a flowchart is to ask 4 things. What information comes in? What decision needs to be made? What action happens next? What result gets shown or produced? That simple pattern helps organize a lot of beginner logic. Now, you have something powerful, a way to turn confusion into a plan. That is what flowcharts do. They help you think clearly, test ideas early, and get ready for real coding. In the next chapters, that logic will start turning into Python. Awesome job! Chapter 4 is finished. You learned how flowcharts turn big problems into clear step-by-step logic before coding begins. Like and subscribe and get ready for Chapter 5, where we start Python and build your very first program.